Hello everyone, I am Dr. Laurent. In this section, we are going to discuss with complex integration formulas. First of all, Cauchy integral theorem. Cauchy integral theorem. Integral over C, f of z, dz equal to 0. Cauchy integral formula. Cauchy integral formula. F of a equal to 1 by 2 pi I integral over C f of z by z minus a dz. So this form rewritten integral over C f of z by z minus a dz equal to this term 2 pi I, just taking in the left hand side. So 2 pi I into f of a, and then the derivative, Cauchy integral formula derivative, integral formula for derivatives. So integral f dash of a 1 by 2 pi I integral over C f of z by z minus a dz, this z minus a square, and then f double dash of a 2 factorial divided by 2 pi I integral over C f of z by z minus a whole cube dz. This form should write in terms of, just rewritten the whole right hand side value, integral over C f of z by z minus a whole square dz equal to 2 pi I into f dash of a, f dash of a, and then integral over C f of z by z minus a whole cube dz equal to 2 pi I by 2 factorial f double dash of a. In general form, in general, f n of a n factorial 2 pi I integral over C f of z divided by z minus a whole power n plus 1 dz. So this term to rewritten the form of integral over C, this is a in general form, f of z by z minus a whole power n plus 1 dz 2 pi I by n factorial f n of a. So this is a Cauchy integral formula derivative. And then Taylor series, the expansion of Taylor series. Taylor's series, f of z equal to f of a plus z minus a by 1 factorial f dash of a z minus a whole square by 2 factorial f double dash of a, and so on, and z minus a whole power n by n factorial f n of a, and so on infinity. So this is a Taylor expansion. In this Taylor expansion, the a value put 0, then it's Maclaurin series. Maclaurin series is nothing but f of z, this Taylor series a equal to 0. So f of 0 plus this a 0 means z by 1 factorial f dash of 0, z square by 2 factorial f double dash of 0, z cube by 3 factorial f triple dash of 0 plus up to z power n by n factorial f n of 0 plus up to infinity. This is a Maclaurin series. And then Laurent series. Laurent series. F of z summation n from 0 to infinity a n z minus a whole power n plus summation n from 1 to infinity b n by z minus a whole power n, where a n is nothing but 1 by 2 pi I integral over c 1 f of z by z minus a whole power n plus 1 dz. Then bn 1 by 2 pi I integral over c2 f of z by z minus a whole power 1 minus n dz. Now this part going to use some basic formulas. The formula is nothing but 1 minus x power minus 1, 1 plus x square plus x cube plus up to infinity, 1 plus x power minus 1, 1 minus x plus x square minus x cube plus up to infinity, 1 minus x power minus 2, 1 plus 2x plus 3x square plus infinity, 1 plus x power minus 2, 1 minus 2x plus 3x square minus up to infinity. These are the binomial expansion basic formula. And then evaluation of residue. The next part, evaluation of residue. Evaluation of residue. Residue of f of z at its simple pole z equal to z naught, then using the formula residue using the notation or residue z equal to z naught, limit z tends to z naught, z minus z naught into f of z when the problem simple pole at z equal to 0. Then the second formula, residue of f of z at its pole z equal to z naught of order n. Then the formula residue r equal to residue z equal to z naught, limit z tends to z naught, 1 by n minus 1 factorial d power n minus 1 by dz power n minus 1, z minus z naught whole power n f of z. And the third formula, if f of z equal to pi of z divided by psi of z at its simple pole z equal to z naught, then our residue z equal to z naught is nothing but pi of z naught by psi dash of z naught. And Cauchy residue theorem, Cauchy residue theorem. The Cauchy residue theorem is nothing but integral over C f of z dz equal to 2 pi I into sum of the residue of f of z at the point z1 z2 up to zn. And then contour integration. The contour integration, two type of problem. One is unit circle, other one is semicircle. Contour integration. So type 1 unit circle. The type 0 to 2 pi, the function of cos theta sin theta into d theta. So this is a form. Here z equal to r e power I theta, because of here x equal to r cos theta, y equal to r sin theta. This is a short form z equal to r e power I theta. Here r equal to 1 because of unit circle. Unit circle means radius 1. So therefore z equal to e power I theta. Now this term should write in the form of cos theta, z equal to cos theta plus I sin theta. So when this term z equal to e power theta, when we are differentiating, dz equal to e power I theta into I d theta. This e power I theta is nothing but dz equal to Iz d theta. So from this equation, theta equal to dz by Iz. Theta equal to dz by Iz. Here z equal to cos theta plus I sin theta. 1 by z cos theta minus I sin theta. When should add these two value, z plus 1 by z. When we are adding I plus I sin theta minus I sin theta cancel. So 2 cos theta. From this equation cos theta equal to 1 by 2 z plus 1 by z. When z minus 1 by z, cos theta minus of cos theta cancel, then 2i sin theta. So sin theta equal to 1 by 2i z minus 1 by z. So very short to remember this. When sin theta cos theta type of problem is given, then substitute cos theta equal to 1 by 2 z plus 1 by z. Sin theta equal to 1 by 2i z minus 1 by z. D theta equal to dz by Iz. So this substitution to substitute, use contour integration form. And then type 2, semicircle. The semicircle is nothing but, now this is a x, this is a y, semicircle. Now this is a real line R to R, then this is a surface, so curve. Now integral over C f of z dz equal to integral over minus R to R f of x dx plus integral over s f of z dz. When r tends to infinity, the semicircle become very large and the real and imaginary imaginary part of any point on the semicircle become very large, so that modulus of z tends to infinity. If r tends to infinity, then the surface S of f of z dz tends to 0. So this is a second type of the problem. So now see, these are the topic to cover. So one is Cauchy integral formula, Cauchy integral theorem, Cauchy integral formula, then the derivative and Taylor expansion, Laurent's expansion. So the Maclaurin is also under the control of Taylor expansion. This is a Laurent's expansion, and then residue theorem. It's covered with evaluation of residue and contour integration. These are the formulas for this complex integration unit. Thank you.